Hello students, welcome you all to the session of Engineering Mechanics GATE 2022 questions Civil Engineering. The first question of the session. An undamped spring mass system with a mass m, spring stiffness k is shown in the figure. The natural frequency and natural period of this system is omega radian per second and time t seconds respectively. If the stiffness of the spring is doubled and the mass is halved, then the natural frequency and the natural period of modified system respectively are. He has given a spring which is been attached with the stiffness K and mass M. Option A 2 omega radian per second T by 2 seconds. B omega by 2 radian per second and T 2T seconds. C 4 omega radian per second and T by 4 second. D omega radian per second and T seconds. When we see this question, the undamped free vibration you can see undamped free vibration of single degree of freedom for the above figure. When we give the natural frequency and natural periods, which are omega radian per second and t seconds respectively, the equation becomes omega is equal to under root k by m, t is equal to 2 pi by omega. These are the basic formulas which you people should know. So, when considering this system, the values of omega and t will be this, and for the modified system, the spring, what is saying, the spring is doubled and mass is halved, right? So let us assume k dash, that is spring constant, got doubled and mass got halved. Then k dash and m dash represents the stiffness and the mass of the modified system. What happens to omega dash under root k dash by m, and that will be root of 2k by m by 2, which will be root 4k by m. That will be 2 root k by m, which I'll write it as 2 times omega, because omega is under root k by m. Simple. I gave you at the starting itself, right? When I talk about t, it is 2 pi by omega. Now, this will be 2 pi by 2 times omega, that is 1 by 2 into 2 pi by omega. That gives you t by 2. 2 pi by omega is t, right? As t is 2 pi by omega. So omega dash and t dash are natural frequencies and natural period of modified systems. So the natural frequency of the modified system is doubled and the natural period is halved compared to the original system. So obviously when we see the answer 2 times omega and t by 2, that is option A, will be the appropriate right answer for the given question. Easy question. This is vibrations topic. Got it? Moving on to the next question. The linearly elastic planar system shown in the figure is acted upon by two vertical concentrated forces. The horizontal beam UV and WX are connected with the help of vertical linear spring with a spring constant of 20 kN per meter. The fixed supports are at U and X. It is given that flexural rigidity EI is 10 power 5 kN meter square, load is 100 kilonewtons, and the distance A is 5 meters. Force Q is applied at the center of the beam. Wx such that the force of the spring Vw is going to become 0. The magnitude of force Q in kilonewton is dash rounded off to nearest integers. So he has given you this question, and in the diagram the distance 2a between u and v and ei will be the flexural rigidity, a and a, that is again 2a between w and x, and the flexural rigidity is also 2ei. If the force in the spring is 0, force in spring is equal to 0, then there will be no deformations in the spring, that is deflection at the point v. Deflection at the point v will be equal to deflection at point w. This is deflections. This is deflection. So when I consider uv, that is, this is 2a, load of P is applied, this is u and v, and if I consider this is w, this is x, centrally acted load, the distance is a and a, flexural rigidity is 2i. So deflection at v shall be equal to deflection at w. That is, what will be the deflection formula? W, that is load P, L cube by 3ei, right? That should be is equal to Q into a cube by 3 into 2ei. That is, I'm talking about this half condition from here to here. Next, plus Q into a square by 2 into 2ei plus length of a. That gives you 8 by 3 P should be equal to 1 by 6 Q plus 1 by 4 Q. I'm taking Q common. So from here Q is equal to on simplifying 32 by 5 into P, which gives you around P is 100 kilonewton given, 32 into 100 by 5. 32 into 100 by 5 will give you around 640. 32 into 100 divided by 5 will give you 640. Right, this will be 640 kilonewton. As given, P is equal to 100 kilonewton. Here you take the LCM 24 and you cross multiply it, so that you will get the value of Q. So Q is 640 kilonewtons. Simple question, engineering mechanics, gate 22, set 2, 2 marks question is this. Only by knowing the basics of strength of material and engineering mechanics, you will be getting the answer of 640 kilonewton, right? So this will be the questions of set 2 engineering mechanics. Thank you, students.